The amount of a certain type of drug in the bloodstream t hours after it's been taken is given by the formula x equals d e to the minus 1/8 t, where x is the amount of drug in the bloodstream in milligrams and d is the dose given in milligrams. A dose of 10 milligrams of the drug is given. Find the amount of the drug in the bloodstream 5 hours after the dose is given. So, x is the amount in the bloodstream, d is the dose given, and t is the number of hours after it's been given. So in this case, d is 10, t is 5, and I need to work out x. So x equals d times e to the minus 1/8 times 5, which is 5.353 milligrams to 3 decimal places. A second dose of 10 milligrams is given after 5 hours. Part B. Show that the amount of the drug in the bloodstream 1 hour after the second dose is 13.549 milligrams. So, after 5 hours, a second dose is given. But there is still this amount from the first dose left in the bloodstream. Remember that this was the amount of the drug left in the bloodstream 5 hours after the first dose. And we have now added an additional 10 milligrams to that. So precisely at the moment when that second dose is given, there is actually 15.353 milligrams of the drug in the bloodstream. 10 milligrams of the new dose plus 5.353 milligrams of the first dose that's still left over. So 15.353 milligrams in total in the bloodstream. 1 hour after that, we need to show that x is 13.549. So let's use our model, whereas this time D is 15.353 because that's the amount that's in the blood. That's like the equivalent of the dose being given, because that's how much is in the bloodstream when t equals 5 hours. So x equals 15.353 e to the minus 1/8 times 1, because it's 1 hour after the second dose, which is 13.549 milligrams, which is what we needed to show. And then to part C. No more doses of the drug are given. At t hours after the second dose, the amount in the bloodstream is 3 milligrams. Finds the value of t. Well, remember what I've said. When the second dose is given, there is 15.353 milligrams in the bloodstream. And that's decaying according to this rule. Let's change the point to this rule, where 15.353 e to the minus 1/8 times t. Now, I've put a capital T there because I'm looking for the precise moment, the specific time when that's going to equal 3 milligrams. I can now divide both sides by the 15.353. I'll take logarithms of both sides. And then times both sides by minus 8. And if I type that into my calculator, I find that it is 13.1. T is 13.1 to 1 decimal place when the amount of blood in the amount of the drug in the bloodstream is 3 milligrams.